In section 3.2, we talk about measures of variation. In 3.1, we had talked about measures of central tendency, where most of the data were centrally located. This section talks about how spread out the data are. So if I had a class of students, 5 students each, and in class 1, these were the ages of my 5 students. Well, what is their average going to be? You're going to say, well, obviously, Professor Faber, it's going to be 22. We have 1, 2, 3, 4, 5 students. Well, let's say I have a class that has these ages. Okay, their average is also 22, but what's different about these two sets of data? Okay, there's no variability in the ages here. Same mean or average or measure of central tendency. This one has a different measure of variability that we will talk about and calculate. So there are some different measures of variability. So we need both the measures of central tendency as well as the measures of variability to describe our data. And this is part of descriptive statistics. Remember, we have descriptive statistics and inferential statistics. In our descriptive statistics, measuring a variation, we have both the range, the variance, in addition the standard deviation, and the coefficient of variation. The range is the easiest to calculate. It is the largest data minus the smallest data value. Looking back at the ages of our two classes, the range of this group, well, we only have one number, 22, so the range is 0. The range of this class is 24 minus 20, or a range of 4. So if a range of 4 years, this has no range in our years. Okay, so let's also look at the data set that we had done from section 3.1, which the example one we had done there was the stop and go convenience chain. And this store monitored the number of times each customer made a purchase. I still have that data in my calculator. Oops, sorry. So if I hit stat and hit enter, I have that list of data in L1. Now I have already sorted the data. So just to remind you how to sort the data, we go stat, stat, and we see sort A, which is either number 2 or we can arrow down and hit enter. Tell it L1, which is again above the 1 key, and hit enter. We go back in and look at our list, and it should have sorted your list. So you can look at the list this way to see the smallest and largest data value, 7 and 22. So we can see the range is 22 minus 7, or 15. Now we also want to look at two other measures of variation, the sample variance and the sample standard deviation. The sample variance, we also have, the population variance. The sample variance is S squared, the population variance is sigma squared. Most of the time we don't have population data, most of the time we're dealing with sample data. But it is very important for you to understand the notation between these two, sigma squared and S squared. These will give you a measure of variation in squared units, whereas the standard deviation gives us the measure in regular units. You can see we just take the square root of the variance. Now on our calculators, there's several different ways we can find the variance and standard deviation. As far as using the formulas, Dr. Mosley in the lecture videos posted in Canvas will show you how to use the formulas, but I'm just going to show you how to use the calculator. Two ways we can do it. If you remember from 3.1, we went into second list over to math, and there were lots of options here. We could go find the standard deviation or the variance of a data set. We could also find the second list over to math, the standard deviation. So you have both the variance and standard deviation. So we can see that the square root of 20.888 is 4.57. Another way we can do it is if we go to stat. This is an important function in the calculator. Over to calc. The very first one var stats. I'm going to tell it L1. Now, if we don't tell it which list here, it will default to L1. You just may want to get in the habit of telling it in case you have your list in L2, L3. Hit enter. It's going to give us a whole list of information with an arrow key, which means there's more information. But let's just look at the beginning part here. X bar is our mean. So our mean of our data set, or our average, is 15. The sum of x we could use when we were calculating the mean, if you remember that. The sum of x squared is actually a value that is used in a computational formula for variance that Dr. Mosley uses. And then we have Sx, sigma x. I just ignore the x because it's referring to the x variable. So we have S and sigma. S and sigma are the sample standard deviation and the population standard deviation. Now, the reason it's giving you both of these numbers here is because the calculator doesn't know if that list is a sample or a population. So you have to know that. You can only use one of these because the population standard deviation is going to be different because you have your whole list. Since I know that this list is a sample, I just ignore the sigma line. Now, I'm going to arrow down and look at the last numbers here. Gives us the sample size was 10, gives us the minimum data value was 7 as well as the max of 22. So we could just go here if we did this and calculate our range. Also gives us the first and third quartiles as well as the median. The first and third quartiles we'll talk about in section 3.3, and we already talked about the median, which is 15.5. Okay. The coefficient of variation is oftentimes used because it is in percents and not units. So if I was comparing the distance that Rhode State College students drive to campus versus the distance that Wright State University Lake Campus students drive to campus, and the Wright State information was in kilometers and the Rhode State was in miles, it would be hard to compare, so we could compare it as percent, the percent of variation. So the coefficient of variation is often used when we deal with percents. You can see it is the standard deviation divided by the mean times 100. So in our example that we just did, our our standard deviation was 4.5704. So we take 5704, and we divide it by our mean of 15 and multiply by 100. So we take our 4.5704. I would do at least 4 decimal places. You can do more if you want, but do at least 4. Divided by 15 times 100. It gives us as a percent. So it's 30.47% variation in our data. Okay? Now, one other thing in this section that we're going to talk about is called Chebyshev's theorem. So Chebyshev's theorem just tells us what percent of our data lie in a certain interval.